Welcome back, guys. So, in our series of PostgreSQL backup and restore, we are today talking about our main topic for this backup and recovery, the point in time recovery. This is most of the time required for your production clusters when someone dropped something or database is corrupted and you want to restore your database. The consistent state of database is required. So point in time recovery is required where someone dropped the database and you want to restore your database just before that time. Okay. So what we have in point in time recovery we'll discuss in this lecture. So let's start the video. Okay, so what is point in time recovery? So it's a feature in PostgreSQL that allows you to restore your database to a specific point of in time rather than just to the latest backup. So like earlier, if we when we talk about earlier things like when we took the backup of our whole database cluster, so if we restore that only, that will let you to the older database state, not to this particular time where you have some other commands. Like if you just restore the base backup and till the time we take the base backup, there are other transactions in the database as well which are completed and required. So for that, applying those changes to the database as well, we first do the base backup and then the wall files, so that all the changes after the base backup will be applied to the database. So this is point in time recovery. Okay, these are called as write ahead logs or wall logs. You can call them wall segments, wall files, anything. So this is powerful feature that helps minimize data loss and downtime in case of various incidents of the in production you require this thing. Okay, so here are a few things in point in time recovery, what's the working, how we say how we understand it better. So first is base backup. Like in our earlier previous video we took the base backup using pg restore command. Okay, so we can use that base backup, and after that base backup we do transaction log backups, that is continuous archiving if your that is running. So one thing here, your point in time recovery works only when you have archive logs enabled, when you have your continuous backup of archive log files enabled, continuous backup of wall files enabled. Okay, so what we have in that, you can watch my earlier video where you'll get to know about what are wall files and how we take archive logs backup, how we do how we put our database to do continuous archiving of wall files. Okay, so that is required before we do the point in time recovery. So in production we must uh, enable our database to use uh, archive log backup. Okay, so we took the base backup which has all the data files table spaces. Okay, you can watch my earlier video to see how we take the base backup, and then we have transaction logs. So these are the parameters for point in time recovery. One is base backup, then transaction logs, which are called wall logs as well, wall segments. So PostgreSQL maintains a series of transaction logs, also known as wall logs, which will be maintained if you, and also if you enabled the point in time recovery, then you can have if you enable the archive log backups, then you can have point in time recovery only. Okay, so it maintains wall logs. These logs contain all the changes made to the database cluster after the base backup was taken. Okay, so if we take the base backup and we have enabled this archive logs, so what it happens, everything we made changes, everything that's going on in our database, any change we made on the database, that gets updated into the wall logs. And once the data wall logs are filled, those will be copied to the archive log segments where we are saving our archive logs. So there's another way we can tell Postgres to switch to wall logs and save the contents of wall files into archive files, but automatically there is a process. Even when the wall logs are full, they will be applied to the archive logs. They will be saved to the archive logs. A file of them will be copied over to archive destination, which we have set in the our earlier video. So that's very much required before going to point in time, because you need to understand everything about base backup transaction logs. Okay, and the third thing is restore and replay. So once we applied this base backup, then we need to do the restore. Okay, for the applying these base backup and then wall logs. So how we do it? You first restore the base backup, create a consistent starting point, then you apply the transaction logs in sequence. There's a steps. There are few steps we need to follow to apply these. Okay, starting from the point of the base backup to the desired recovery time. So Postgres provides a pg wall replay resume function for the recovery.configuration file to specify the target recovery time. We can in this configuration file we have target. Earlier we have recovery.configuration file, but after Postgres 12 we do not have this recovery.conf. We have postgres.configuration file. Okay, postgres.conf. So recovery parameters are uh, handled using postgres.conf file. We'll see when we're talking about these in the lab. We'll see how we do it. So in postgres.conf we need to make these changes. Restore command. First we need to go for this parameter, restore command. Okay, and then we need to this is used to retrieve archives segments of wall files. So you need to place the archive destination here. Okay, and then it will copy the this is our copy command, so that it will the Postgres will copy the files from archive segment to the Postgres cluster using this command, restore command. Then we have recovery target, which may be immediate. This parameter specifies the recovery should end as soon as consistent state is reached. So if your database is corrupted, so you can use just recovery target to immediate. So um, it will be in the position before the your database gets corrupted. The next is recovery target LSN. So this parameter specified the log sequence number of your write ahead log location up to which the recovery will proceed. So every transaction database have a sequence number. So that if you specify any log sequence number, so database will be recovered up to that. So there's one another function parameter recovery target name. These all you will see in recovery targets. Okay, this is required. A recovery command is required, and apart from this recovery command, any of these parameters are required: recovery target LSN, target name, target time, xid, and there are other parameters as well. These are as well. Okay, so recovery target name, this parameter specifies the name of restore point, named restore point. If you take the backup and if you take the any restore point for your database earlier, you can name that restore point and your database will be backed up. Sorry, up to that restore point. Okay, recovery target time. If you know any time up to you want your database to be backed up, you can mention that recovery target time. Uh, you in our lab I'll show you this. Okay, because we are working on our local system and we can specify any time, so we'll be working on this one in our lab. Recovery target xid. So this parameter allows you to specify a transaction id as target for recovery. Transaction ids are like unique identifiers assigned to each transaction in Postgres. So if you want your backup for particular up to a particular transaction, you can mention that transaction XID here. Okay, transaction ID here. The another parameter is recovery target inclusive. This is the important parameter, and it is used to control whether the recovery should include the transaction specified by transaction target XID, transaction ID time, or transaction target LSN, transaction target. So this parameter controls all other recovery parameters. So when this parameter is true, okay, when this parameter is true, the recovery target inclusive. So the transaction or timestamp specified by these parameters or earlier parameters, that will be included in recovered state. Okay, so if we specify any transaction LSN or transaction name, target name, or transaction time, transaction XID, so that will be included in when we recover it. So, and if this target is false, if this parameter is false, recovery target inclusive, this is false. So if we put anything here, recovery target time, XID, and target LSN target, so if this is false, the transaction or the time spent stamp specified by the parameters is not included in the recovered state. So you will get your database recovery before things mentioned, before points mentioned in these parameters. Any of these, it will the recovery of that will be before this. Okay, so if you know that with this transaction uh, transaction ID your database gets corrupted, so you put that transaction XID here, and then you can use this parameter to false, so that you will get your database recovered before that particular transaction. So this is the main parameter which controls all of them. If you do not set it to anything, the default value of this is on. Okay, if you turn this off, then recovery will end before the mentioned recovery target. Okay, so by default this is on. Okay, which is true. So if you mention anything and you do not set this parameter to anything, if you mention anything here, so recovery will be till this time. Okay, so this is all. And okay, so let's talk about steps. This is all about the parameters for recovery, and we are going to talk about steps for point in time recovery. So first we need to stop the server, copy the data directly to another location, remove data files. We are doing those in our lab. Okay, so we are doing the remove of data directory, and then restore from the base backup the data directory with the pg restore command or any other command. I'll show you. Then remove if there are wall files, like we have when we are taking the backup we saw the wall files, so we can remove that as well. Okay, or we can just take the base backup restored. If there are unarchived wall segments, from if your database is crashed and you saw your some wall files are unarchived, you can take the copy of them and store in the wall segments. Okay, pg underscore wall, you can store in there. Set recovery configurations, and then create an empty file name recovery.signal. I'll show you what this recovery.signal file is. This is very important file. This will tell your database to do the recovery, to start in recovery mode. Then you need to modify pga.hpa.conf so that you are preventing all other users to connect to the database once your database is started with this. Then start the server. Okay, and then you need to, then recovery dot signal file will be uh, your database will look for this recovery.signal file, and then once the recovery is completed, this file will be automatically removed. Okay, so then you can verify the database and modify pg.hpa so that your database will accept the connection. Okay, so that's all about these steps for point in time recovery. In our next video, we'll be talking about how we do the lab for this point in time recovery. Okay, so thank you all, and I'll be seeing you in the next video where we are doing the point in time recovery in lab in with the commands and everything we are doing in real time basis. Okay, so thank you, and I'll be seeing you in the next video.